an opportunity to share my knowledge with all of you. So today I am trying to give a talk on basics of the course of dimensionality and CNN model. So in this talk, I would like to cover the concept of course of dimensionality. Or I'm switching off my video so that it will be bandwidth will be less. So in this talk, I am trying to describe on basics of course of dimensionality and the CNN model, and how the CNN model came to the picture, and why people are fascinated towards the concept of CNN model. I would like to highlight in this talk. So before that, I would like to mention that I am a faculty at IIT Jammu in Department of Electrical Engineering. And I think if I'm changing the slide, it is visible to you.
Yes, this is
Okay. So this is the IIT Jammu campus. It is a newly established IIT, and it is the only IIT in North India, where you will find we are in our main campus, and this campus is totally spread into 450 acres, and it has 5 departments are there. Six departments are there, and now it is growing, and one of the fastest growing IIT in the country. And you will find this is a very scenic and very beautiful place with many research facility. You will never find it in any other IIT which are newly constructed. I would like to invite you all, if you get a chance to visit Jammu, then please visit IIT Jammu, and I will be there to help you in uh, witnessing you for introducing the campus. So first slide, I am starting with the concept of artificial intelligence. So I think many of us are working on this area, or many of you are aware of artificial intelligence. Artificial intelligence is the power of machine to copy intelligent human behavior. Is to say that if I want to design a machine which will rule or which will perform its task by copying the intelligent human behavior. So I think you might have seen many movie or many kind of applications where artificial intelligence are mainly used, starting from robotics to many other applications like biomedical and diagnostic applications. So as you are aware, currently all industry are revolutionizing themselves to artificial intelligence. So starting from a small machine to higher order machine, what we are using in regular life, they're trying to use, or they are trying to the best for going for implementing artificial intelligence. So these are some latest AI project across industries. So you might have seen this first one. It's a robotics application where robots are mainly used for witnessing the monitoring patients. So during COVID-19, you might have seen many doctors are not agree to treat the patient directly. They put some robotics. So usually with robotics, they are trying to uh, check the patient's condition, or they try to diagnose the patient condition, and then they refer to different medicines or different doctors for further. Second application, you can see the self-driving car. Self-driving car is a currently revolutionizing concept. So started with the Google Drive self-driving car first, and then it is revolutionizing many other private agency who are using self-driving car. I think you might have heard the concept of Tesla is the first manufacturing self-driving cars, and mostly in use, or mostly US, they are trying to first install the system for self-driving car. Third application is voice assistant. Nowadays, Alexa and many other application which are coming with. I think Alexa and Siri are the mostly common used voice system in different platforms for AI application for voice assistant. Definitely healthcare, starting from the medical diagnostic operation of a patient, or diagnosing the tumor and operating of tumor. healthcare application also AI is used. Fifth thing, you will find that consumer electronics nowadays, if you have any appliances in our home is affected by any kind of malfunction or anything, we are using diagnosing with a mobile app where it will check the condition of our appliances and it will send a signal to verify if it can give a solution, instant solution, or can connect with us the proper engineer to diagnose the system. Definitely, financial advisor is a very common thing nowadays with which needs AI-based prediction to know the market condition, and based on that, all transactions are now using AI-based projects. Now, if you see AI magic wand, it's a very big umbrella. So, field of AI is a quite a big umbrella, and you will find that machine learning is a kind of tools mainly used to solve this problem. So AI is a bigger umbrella, and there is a very small umbrella is there machine learning, what we are saying. So it is used to solve the AI problems. Now, if you say deep learning is another smaller version of it. So AI umbrella is very big, and deep learning is a small technology which is used to solve the AI problem. Now, in this talk, I am trying to go with this deep learning concept, starting from why this deep learning concept came and why people are fascinated towards deep learning, or you can say why currently all the research are diverting towards deep learning. Now, starting with a regular scene, you might have seen this kind of pictures earlier. Now, let us understand the scene. One of the important thing is recognize or understanding. So this is a quite common practical problem in any kind of robotics, or you can say vision application. So let us assume I will ask you, or I will give a picture to the robot and I will say, please recognize or understand this. Now, let us assume we have three scenes are there. First scene, second scene, and third scene. Now let us assume we are asking a human observer to identify which scene is the best, or you can say which is more scenic picture. Now, if you ask someone, definitely people will say first scene or second scene or third scene based in the perception or perceiving capability. So let us say I am perceiving the third scene is the best, then I can say that third scene is the good for me. But now, if you are going for AI world, let's assume I am designing a AI system which where a robot will be there, or you can say some application where one robot will be asked to identify which scene is the best. The robot will try to extract from this picture and will decide that this scene is very good. Now, one of the ways it has to extract some features. What are these features? What is the scene content is there? So definitely, if you ask a robot to check what are the scenic content are there, definitely tree are there, tree leaves are there from this view, and then take a decision to identify or take a decision to say which scene is beautiful. Now, all this combination what you are seeing is a combination of automatically extracting the features and take a decision based on the uh, computer capability or robot capability. Now, all these things need is two tasks. One is you need a feature extraction algorithm, or you can say to extract the feature some algorithm is required, and then to take a decision using some decision theory, or you can say machine learning can be a good tool to take a decision. What exactly this machine learning is doing, as you know, for last I think 40 years, machine learning is ruling many of the industries, starting from mechanical to computer industry. Machine learnings are used in different way for different part. So if you define the machine learning is a field of computer science that gives computers the ability to automatically learn without being explicitly programmed. So if you give some data to computer, it will try to predict the output considering previous observation. This is the case what every industry machine learning is doing. So machine learning has two parts, training and prediction. So in training process, we have some data, or we are saying it's a training data. So in using this training data, it is building some machine learning algorithm to prepare some decision surface or decision plane. Now in prediction process, some new data where we need to predict the output as a given to the input to the trained model. So based on this trained knowledge model, the testing data or prediction data is predicted what will be the corresponding output. So now let us assume the example what we have considered, that we have some scenic beautiful scenes are there, and we need to say which scene is very good or which scene is beautiful. So we can divide it into two parts. So we have to give the robot or the machine learning system some training data initially to train a system to predict whether this scene will be beautiful or not beautiful. Now, if you go for machine learning, as I mentioned, two things are very common. So one thing is training, one is testing. So in case of training, we are using the previous experience, or you can say based on the training samples, it is creating some an experience to train the system. And with respect to that trained system, it will try to measure the output or predict the output. Now, considering this thing, there are three branches of machine learnings are there: unsupervised learning, supervised learning, and reinforcement learning. So where unsupervised learning, you might have heard of the concept of clustering, dimensionality reduction, all this came into picture. Similarly, in supervised learning, there are many concepts are there like classification, regression, and many more are there. And in reinforcement learning, you might have heard the term real-time decision, robot navigation, AI games, all these things are coming into picture. Now here in this class or in this talk, I am trying to concentrate on classification part and mainly to using neural network concept. So what is the problem in traditional machine learning system? First, we need to identify. So what exactly traditional machine learning system is doing? Giving some input data, it is trying to extract some feature, then training the system with that feature, and when new data are coming, it is trying to predict the output. So let us assume there is a picture you are seeing, there is a koala picture is there. So I am trying to give this picture as an input to the system, and I am trying to predict if a new animals or pictures are coming, I need to predict what will be the animal. Now just think, if a forest is there, there are different animals are there, and I am putting a camera over there, and I am trying to predict what will be the corresponding animal, or you can say what is the animal coming into the jungle. Now, if you are seeing such pictures, so what exactly we are doing? In case of design machine learning system, we have to design some kind of algorithm where handcrafted feature will be extracted. What will be the handcrafted features? There are different algorithms are there where you are using them to extract feature from the images, or it can be image, it can be speech signal, it can be signal, normal signal what we are using a regular life. All these things you can be used to extract the features. So given an image, you are using handcrafted feature extraction, means you are using a separate algorithm which is trying to extract the features from it. Using that picture, we are trying to design a machine learning system to be trained, and after the training is over, the new samples, that is the new pictures of different animals are coming, and I am trying to predict what are these animals. So this is a kind of traditional machine learning system is doing. The problem is that if this kind of systems are used, sometimes it may happen that it is often overspecified or incomplete data are there. So let us assume if koala pictures is like this, I am giving, definitely it will search a picture. If exactly similar type animals are there, it will try to predict. Now let us assume some animals is coming which are having some problem. Let us assume the koala is having affected by some kind of disease and its skin is ruptured. Now just think, if you are giving that picture to system, it will definitely not identify this is a koala. And definitely, if you are using such system in this application or many other kind of application, it will be application dependent. So let us assume I am using this for identifying animal, it is fine. But tomorrow, if I will use it for treatment of animal, definitely it will not try to give you any output or any required output. The third thing is that when we are seeing this kind of system, different application, different features are required for me. So let us say I am going to identify the animal. I am using handcrafted feature. So tomorrow, if I am trying to use it for some other application, some other kind of features or extraction is required. Now, if these things I am going, then definitely validation is required and choice of the handcrafted feature extraction algorithm is also required. So in this case, you may need two tasks, design and validation, or you can say choice of algorithm and validation is required for designing such kind of machine learning system. Now, before that, we should know what is a handcrafted feature. As I mentioned, that handcrafted feature is important. Definitely, handcrafted features extraction we should know. Now, handcrafted features are many a type, mainly used in normal applications. What we are using is a global properties of image or local property of image. So when I am saying global property, it can be intensity histogram, what you are plotting from the images, or it can be average gay level information, what you are taking from the images. So when I am saying local properties, it can have lines, textural details, shapes, structure, many other things come into picture. Now there are many handcrafted features extraction algorithm. One point of time or other point of time, we many of us used in different applications like age, contour, Harris detector, eigen features, shift feature, HOG feature, LBP feature, hair feature, Fourier feature, DCT feature, wavelet, contourlet, curvelet, like this many features we have used in our lifetime to extract different kind of handcrafted features. Now, what exactly these features are doing? Okay, so let us assume you are having a truck. You can see here some trucks. Now, if you see, there are some informations are embedded in every kind of pictures. So what are these information? So if you see this truck, it can be one structure, can be one component, or can be see, you can see many kind of patterns which are available in the truck can be considered as a some important feature. Now global feature and local feature, based on that you can use some important attributes to extract information. Now, mostly if you see many kind of computer vision application, you will find that local features are quite useful because these are invariant. Means if your truck position is varying or your rotation, variation or shearing, anything happen in the scene, it will not vary. The feature will not change. That's why mainly local features are used. Now just think if you want to go for identify this truck available in some other picture. So let us assume this truck is there and this is manufactured by, let us assume Tetra is a company which is manufacturing some army trucks. So let us assume I want to identify where are the other place where Tetra truck is running in the world. And what I have to do? I have to put many kind of cameras at different places in the world and I have to watch wherever there is a truck is going, I need to say that this is a Tetra truck. Now considering this application, just think if I can extract these local features which are shown by these rectangular blocks or yellow color rectangular blocks, I am extracting these features using some kind of algorithm. So these are mainly handcrafted features. So it's a kind of example of shift feature, scale invariant feature transform based features are there. So these features, whenever I am going to some other figure, I am trying to identify where these patches are there or wherever these features are located in the other place. Based on that, I am identifying that this is the uh, correspondence frame or correspondence place when there is a truck is available or this same place, same truck is available. Now, advantage of local feature over global feature is that its locality, means features are local and robust for occlusion, clutter, and many other kind of segmentation algorithms or you can say without prior segmentation also you can use this feature for tracking. Similarly, distinctiveness, reason is that these are individual features and can be matched to large database for objects. So like as I mentioned, that tetra truck is there. Tetra truck has several specific patterns are there. If I can extract those patterns, I can identify in the world wherever the tetra truck is there. If I can build a surveillance system or camera to watch this. Definitely quantity. Many features can be generated. Considering small objects also you can generate features. Since you are going for real-time application, efficiency will be high because you are taking very constituent parts of the images. And you can extend it to larger application or wide range of application. That's why it is extensible also. So that's why people used to use many kind of local features for many kind of application, or based on their application people. Now, one of the example, I think we have gone through this example in many pattern recognition books, where it is trying to distinguish two kind of fish, that is katla and roe fish. You can sea bass and katla fish, you can say. So here you can see an example. So there is a conveyor belt is there, or a fishing industry is there. So where they want to identify which one is sea bass and salmon is there. So two examples are there. So they want to distinguish that using a conveyor belt installed with camera. So you can see there is a camera installed here, and through conveyor belt fishes are coming. So once the fish is coming, the system is going for pre-processing it, or you can say the images it is acquiring from this camera, it is trying to recognize what kind of fish is there. So it's a machine learning kind of application where one machine learning system will be there and it will try to identify whether it's a salmon fish or sea bass fish. Now, as you know, salmon has some kind of particular length is there, and sea bass is having some other length. So you can see sea bass has higher length and salmon has lower size is there, or lower length is there. Now if you plot it, so you can see there will be many kind of mixing will happen, or you can say confusion will happen. Reason is that the small size sea bass will be easily identified as a salmon fish. So it is may not able to classify them correctly or accurately using conventional methodology. So one way to solve this is to go for some other features, or you can say possibly to add some kind of other feature to it. So one way is to consider lightness, or you can say weight correspond to the fish. But if you are taking weight correspond to the fish, then you can see that sea bass or smaller size of sea bass will be easily identified as salmon fish. So this will not able to distinguish them properly. Now people started using both feature, lightness and width, or you can say length of the piece and the lightness of the piece. People started using. So if I am going to use the both feature and I'm projecting all these piece to two-dimensional plane, so you can see the corresponding point presentation in two-dimensional space. Now here you will find that sea basses are completely going towards upward right, and salmon is coming towards left side lower part in a two-dimensional plane. Now, if I want to distinguish the salmon and sea bass in training samples, so initially I am going for training the system. So in training system, what I can do, I can put a very good decision boundary or decision surface to separate salmon and sea bass. The problem is that if you are going for this distance surface, definitely small kind of variation will be there, or you can say small kind of mismatching will be there. But case is that this kind of decision surface are very well established to in machine learning literature to distinguish or kind of going for different kind of classification tasks. But case is that what will be the number of dimension you will go on increasing to get a very good classification. So if you want to go for identifying salmon and sea bass, as you see that if I am taking only one dimension to use it, definitely it will be not sufficient. So you are going for higher dimension. So as you have seen, the lightness and width, if I am taking, or length I am taking, it is very good classifying, or you can say the system is supposed to classify them very well. Now, if I will see that if I am increasing the number of samples, for me preparing the decision surface, or you can say if I'm using a larger number of points or training point to make the system, there are two ways to make the system. One is to consider a linear decision surface, where a linear straight line equation you can consider to separate out both the category. Or I can consider a nonlinear curve to design the decision surface. The problem is that if you are going for adding on more nonlinearity, the system will be overfitted. So it is required to consider some kind of decision surface design, or you can say linear or non-linear decision surface, whatever you are designing, it must satisfy many criteria. I'm not going on to that details on the details. Rather, I will say that overfitting must be avoided such that the system will perform very well. This is an example. Actually, it's a non-linear surface with a good, or you can say generalized less risks decision surface, where you can take a decision very easily. Now, one of the important part you will find in this handcrafted feature extraction algorithm, like I shown an example, that you can consider weight of the piece, length of the piece, you can say color of the piece, like that many kind of features you can add on. And definitely if you are going for high amount of features, or generate higher amount of features, then you can definitely go for taking a good decision. But most of the important part is you have to add on only important information. That means you have to extract the meaningful information, though that it can be useful for taking decision. Or you can say the meaningful information or useful features you need to extract so that you can discriminate different classes. However, deciding that which features are useful, that is not possible in machine learning classification system, which you don't know which features are supposed to be redundant feature, which features are good features. So it is trial and error basis. Everyone is going with different kind of features to decide whether this feature is good or not. So now if you see any kind of application you are considering, you are trying to put many kind of features and checking if that feature is giving you good accuracy or not. If it's good accuracy, then that feature is good for your application. If it is not giving good accuracy, this feature is not good for my application. I am discarding that. Now, based on that, you have to discard the redundant feature and accept the good features whatever you are using. Now, there are many kind of applications are there, and based on your kind of task, you need to choose this feature. But case is that when you are going for higher number of features, it may create a many problem, like it may confuse the system, the machine learning system what you are designing, it can be confused. Or you can see that many kind of traditional signal processing applications are there, and it says that if you are increasing the number of features, it may create problem in your uh, decision capability. This creates the problem of traditional machine learning problem. We are saying it as a curse of dimensionality, and it says that the system or the many machine learning system problem become exceedingly different if the number of dimensions of data is very high. That is to say that if you use to create many number of features, or you can say if you are increasing the number of features for your application, definitely your output of the system is not supposed to be good, or your performance of the system may reduce. So this kind of concept is called as concept of dimensionality, and there is a very beautiful phenomenon out there. It's called as Hughes phenomena, or picking phenomena is there. So this says that with fixed number of training sample, the predictive power of a classifier or regressor first increases as the number of dimension or feature used is increased. but then decreases. This is to say that if you have let us assume 10% data in your classification process or machine learning system you are using for training sample, and if you are initially giving some kind of higher number of dimension or higher number of features to your system, so initially, the performance of the system will be very good, but later on, it will try to reduce the performance of the system. So previously, people have a belief that if you are increasing the number of dimensions in the system, it is supposed to give you a good performance. That stands cancelled, or you can say that point was not valid. It says that if your number of features you are increasing, definitely the output, the performance of the classifier goes on decreasing. So this has many applications. It is proved that if you are increasing the number of features or if you are increasing the feature dimension, your performance of the system will be reduced. And this problem is popularly called as curse of dimensionality problem. And it has been proved in many applications starting from speech recognition, object detection in image, image classification, image segmentation, object recognition, many applications it is already proved. This is the first problem you will find in any kind of machine learning system. Now, second thing is people have started using biological neural network concept in mathematical model, and they termed it as a neural network. So as you know, a neural network is an exact analogy of biological neurons where a nucleus is there and the signal which you are transmitting to different neurons in the system, it is modeled mathematically. So I want to come with a specific example. So what this exact concept is using, many of the time you have heard that it is emulating the concept of biological neurons. So biological neuron works in a particular hormonal flow in a neurons of a human being. So what exactly happening is, if let us assume one person want to do something or any task, all these are controlled by biological neural information processing. So you might be knowing, so let us assume I am feeling thirsty, then what is happening is the gland or buccal cavity gland which is getting dried off, it is trying to send a signal to neuron so that it will control the hand to take a glass of water to drink. So exactly it is trying to send a signal or hormonal through axons. So axon is a branch where the signal from one neuron to other neuron is passing, or you can say synaptic or dendrites which are connecting one neuron to other neuron is trying to send axons or trying to send a signal through flowing some kind of hormone or liquid through the brain. Now, while doing all this activity, so if it exceeds a particular amount of hormonal flow, it will try to send some kind of charge. So if some amount of charge is flowing in the brain, so that amount of charge will create some action in other part of axon terminal or dendrite to do some tasks. So like I am feeling thirsty, if some kind of signals is sent by the brain from one part to another, then I am picking a glass of water to drink, and so that my thirstiness will be over. Now, so same thing is modeled by mathematical model. So where if you are going for different kind of signal connected through weights, it is trying to give you some kind of linear function where we are adding a non-linearity by activation function to get an output. Now, people have started using this concept in the form of multi-layer perceptron by Saibenko in 1989, and it is found that mostly in universal um, problems, it is found that neural network is performing very well by considering some number of hidden layer on it. Now, if you see from 1990 to 2005, extensively neural networks are used for many kind of machine learning tasks, or you can see many of the industries started using also the concept of neural network for different kind of applications. Now what exactly it is happening, it has some kind of layers to calculate the output. So if you see, let us assume one single hidden layer is there and we have an input layer and one output layer is there. So if you connect it, so you can see, considering two hidden layers with one with 4 nodes, another with 1 node. So you will find that every node in the input is connected to 1 node in the hidden node. So every node connected to 4 nodes. So 4 into 4, total 16 connections are there. After that hidden layer, you will find 4 connection, and output layer 1 connection is there. So in this way, the system is trying to train the weights corresponding to this neural network to go for any kind of classification task. Now, if you see this kind of calculation, so everywhere there is a softmax operation is there, where you are saying it's an activation function or non-linearity function which is added to the system so that it can perform a very good task. As I mentioned that if you are going for such kind of calculation or such kind of operation, you can find for simple this kind of application for processing in your computer, at least you need almost 21 calculation here. So 4 into 4 plus 4 plus 1, so it will be 21 calculation is there. Now just think, if you are considering an image of size 400 cross 400, just imagine whatever mobile images you are capturing, it is coming around 3000 something into 2400 or 2100. Considering that I am considering a small image of 400 cross 403, if I am using the same architecture, that is one hidden layer with 400 cross 403 collection and one second node with 1 node, a second layer with 1 node, so you will find that approximately 230 billion collection will be there, or 230 billion parameters to be computed by your system. Just imagine, if you are taking an image of size 3000 cross 2000 size, this parameter or this calculation is supposed to exponentially grow. So if you are going for any simple kind of calculation in your neural network, you can imagine for a 400 cross 403 image, you are doing almost 230 billion calculations. Here is the concept of deep learning. So there are two disadvantages as I mentioned. One is curse of dimensionality. Second, if you are using any neural network, you are going to have 230 billion calculation in case of your any kind of machine learning application. And definitely choice of any kind of feature extraction algorithm, what I mentioned as a handcrafted feature extraction algorithm, is also an important task. Considering these three problems, so first problem is that you have a problem of choosing which handcrafted feature extraction algorithm will be useful for you. Second thing, you need at least 230 billion calculation for any kind of neural network you are considering for your application. And third thing, that there is a concept of curse of dimensionality, because you don't know how many features are useful for your system and which are the features useful for system. So if you consider these three problems, then that creates a problem for you how to resolve these three problems. So these three problems are supposed to be resolved by the concept of deep learning. So here plays the important role that deep learning is trying to bringing out you out of all these problems what traditional machine learning systems is unable to solve it. So this is the main reason why everywhere you will find that people are fascinated, or complete industries are ruling out over the traditional machine learning system and going towards deep learning system. Now you will find that everywhere, starting from internet cloud, medicine biology, media entertainment, security defense, autonomous and make it autonomous navigating vehicles and autonomous machines, everywhere people are trying to use deep learning technology for any kind of machine learning system what people used to do earlier. So why deep learning and how this deep learning is solving? Let us go for it. So previously what koala picture was there, which is supposed to train your system and trying to identify the animal. So previously your system is trying to use the deep learning model, traditional machine learning model, where the concept of handcrafted feature extraction algorithm is there, Now it is replaced with a deep learning architecture where these deep learning models are trying to extract the feature, whether it's a low level feature, mid level feature, or high level feature. It is trying to be extracted by the deep learning algorithm. Exactly in this deep learning algorithm, another part is there where the system is classifying your data based on this all these extracted features. So trying over to distinguish your existing machine learning system and deep learning system, you will say that let us assume I have a system to identify a picture taken of car and non-car vehicle, or you can say different vehicles are there. I am trying to identify whether it's a car or not a car. So it is time to take a picture. So in traditional machine learning system, there is a feature extraction algorithm, or you can say there is a hand-crafted feature extraction block was there, which is trying to extract the features and feeding it to a classification process that is a neural network system to distinguish whether it's a car or not car. But what deep learning system is there, in deep learning system, all these images are fed into a system or deep learning system, which is a combination of feature extraction and classification, both are there. So previously you are using a specific architecture for feature extraction where you are not sure which features are important for you, and definitely if you are giving more number of features, it will be redundant for you and it is trying to bias and give you a solution which is not good for you. So there are two problems are there previously. What is the important features for you and which feature is important for you. Previously you don't have a choice. You are trying to try with 100 feature extraction algorithm. Whichever feature extraction algorithm is good, you are trying to use it by your system. But here there is no such. Your system is trying to extract the feature which is important for you, and based on that feature it is trying to classify it. So previously I am giving a picture of car. It is extracting using handcrafted feature extraction algorithm, feeding it to classifier. It is saying whether it's car or not car. Here I am giving the images to the deep learning system. Deep learning system has all these feature capability. It is trying to say whether it's a car or not car. So this part is reduced by a single step. Now, considering this concept, if you see the architecture of machine learning, where we start, you'll find that people started with sparse neural network concept in 1940, whereas 1960-70 people started with a multi-layer neural network with backpropagation algorithm. Further, you can see k-mean backpropagation algorithm to neural network, stagnated neural network, decision tree, Bayesian network, support vector machine, widely started used in 2009. So you can say there are many kind of architecture people have used or tried to use till 2009 to solve different kind of problems. But in 2012, first time AlexNet concept came. So whatever you are saying, deep learning concept, it started in widely in 2012, where people started using AlexNet, BGGNet in 2014, ResNet in 2015, 2016 DenseNet, 2017 WGAN, Deep Forest, all these concept later on came, and people are widely using this concept in many kind of problem solving. First thing, why this concept came and how people thought of going through this kind of application. So people started this concept from the one of the important database which are used or which is called as ImageNet database. So you can see here in the top left it is written ImageNet. So this is a very large database which is composed of 1.4 million images with almost 1,000 different classes are there. Later on it is goes on increasing and it is now I think 2.1 million with around 2,000 some object classes are there. So it is a larger challenge for image processing community. So where the task is to identify or classify these images into different categories. So when people started using all this concept, so people started with a different kind of you can say applications. So till 2010, with the concept of swallow neural network, whatever I developed using multi-layer perceptron and other things, people are getting an error of 28.2. So you can see in 2010, people have got maximum error of 28.2, or you can say minimum value of this or accuracy, whatever they got with 28.2% error. Now in 2011, smaller neural network is improved to get a 25.8 error, or you can say with a lower accuracy of 25.8. But later on, when people start using AlexNet and different version of this deep learning architecture, it is recorded that in 2015, the accuracy is so highly improved and only 3.57% error was there. So you can see later in 2016, 17, 18, 19, 20, 21, and 22, this accuracy is further reduced, and you can imagine using the use of deep learning concept, how this classification task is giving a very good accuracy over this large database, which is widely used for image processing challenges. So all this industry, as I mentioned, due to this ImageNet challenge, people are diverting towards deep learning. So one of the important algorithm people have used is CNN model. So it is called as convolutional neural network model. So which uses matrix convolution operation over the multiplication or the addition operation what people have used earlier is ruled over using convolutional operation. So this complete model is operating on convolutional operation instead of matrix multiplication or addition operation. So this is a typical architecture of a convolutional neural network where input images are there, and there are many stages of convolutional first ReLU and pooling operation are there. So I will try to extract or describe all these operation details so that it will be useful for us to understand what is a CNN architecture. So this is a typical architecture for convolutional operation. So convolutional operation, many masks are used. So mask, or you can say that the kernel function is there. So if you are having RGB image, let us assume you have an input image and you are feeding it to a CNN model. What CNN model is doing, it is trying to first extracting the channels, red channel, blue channel, and green channel. First it is extracting. After this, it is trying to put kernel. So red kernel, green kernel, and blue kernels will be used. And all these kernels are composed of different weight values. And if you see any kind of neural network application or machine learning application or deep learning application, it is trying to learn this parameter or the weight function for your application. So it is trying to collect or trying to build a structure of this kernel based on the training samples. So what we are exactly doing, we are putting this kernel over every pixel location in the image and trying to compute what will be the convolutional output at that location. Once you are getting red kernel output, green kernel and blue kernel output, we are adding it up to get the output channel or output of this convolution operation. So this kind of operation is called as convolutional layer operation or convolution operation using mask. So let us consider one example. You have a 32 cross 32 cross 3 sides image. So when you are using a filter or a kernel of 5 cross 5 cross 3, so you are trying to have 3 images here and 3 filters here. So as I mentioned that if you are having a RGB image or you have an image which is having 3 channels, you must have to use a filter with 3 channels. So if you are having an image of 3 channels and if you are using a filter of 4 channels, it is not possible. So you have to use exactly same number of channels for your application. So what exactly I am doing? I am trying to put it every pixel location and compute the matrix convolution operation, what I am saying previously, whatever example I have given, and it is trying to take an operation of wx plus b, which you are doing in your neural network previously. So all your neural network operation is now replaced with the wx plus b. So you are trying to train your weights, this weight function correspond to these kernels using your training samples. So it is supposed to give you an activation map of 28 cross 28. As I mentioned, if you are going for 32 cross 32 cross 3 with a 5 cross 5 cross 3 filter, since you are putting your filter or mask over every pixel location, the boundary pixels will be excluded, and that's why you will get an activation map of 28 cross 28. Now, if based on your number of filters, so let us say I am using 6 filters, so I am getting definitely 6 output images or activation maps of each 28 cross 28. So based on the number of dimension, or you can say number of convolutional operation, I can extract many informative features. So if I am going for one convolutional layer, so definitely first pass out will give you low level features out of it. If I will go for two convolutional layer like this, I will go for mid level features, or you can say important attributes like this. If I am going for three operation, then high level features I can extract from the images. So if I am going for n number of convolution layers, definitely I can extract more level of depth features out of these images. Just think, previously those who are trying to use different kind of or scaling features like you can say wavelet, curvelet, or contourlet. So you are trying to extract more meaningful information, or you can say you are trying to use many kind of scale, different scale features using your signal processing application. Now you can use those features using easily by convolutional operation using deep learning architectures. In exactly similar way, there is a concept of strides is there. So the stride is to say that how many times you will shift your mask over the image to extract the feature. So let us assume you have a 7 cross 7 image is there, and you are using a 3 cross 3 filter or 3 cross 3 kernel or 3 cross 3 mask. So definitely if you are putting at every pixel location, then I am saying it's a stride equal to 1, which is supposed to give you output of 5 cross 5, excluding the border pictures, border pixels. Now, if I want to shift it by two strides, stride 2 means I am trying to shift it by two locations. So previously this location, or you can say this position, now I am moving to this location, or the 2 pixels I am taking over. So then I am saying it's a stride equal to 2. If I am going for stride equal to 2, then I am trying to produce an output of 3 plus 3. Now, if I am trying to put a stride equal to 3, then I am trying to push it on a 3 pixel. But if I am trying to go with a stride equal to 3, just see, if I am having first pixel here, then 1, 2, 3 will be second pixel, 1, 2, 3 will be the border pixel. So this is not possible. So this kind of operation is not possible because it doesn't fit in it. So there is a conventional calculation is there, that if f is the number of size of the kernel and n is the image size, then stride can be possibility calculation you can do like this. So n minus f divided by stride plus 1 if you are taking, and if it's an integer number, then you can say that this kind of stride calculation is possible. And if it's a floating point number or a not an integer number, then you can say that this stride is not possible. So like this, strides are calculated. Similarly, there is a concept of zero padding is there. As you have seen that if you are going for n cross n size image, you are putting f cross f size mask, you are trying to get an output of 5 cross 5, 3 cross 3 like this. The problem is that if you are going for such kind of calculation, many informations are going to be lost. So for that reason, people are going with a stride of zero padding. So zero padding concept is saying that if you are using a f cross f mask, then f by 2 will be the number of pixels will be padded with 0 in all dimensions, that is row wise, column wise, in all possible side of the image. So you can see here, if you are applying for 7 cross 7 size image with 3 cross 3, so if 3 cross 3 filter is applied, then 3 minus 1 divided by 2 will be the number of pixels which will be padded with 0. So you can say 3 minus 1 divided by 2 will be 1. So 1 pixel border in row wise above, row wise in the below, row wise in the left, and row wise column wise in the left and column wise in the right will be added with 0. So you can see here, this is a common example of 0 padding with 1 pixel. So definitely if you are going for 1 pixel 0 padding, so you will definitely get an output 7 cross 7 as compared to previously you are getting a 5 cross 5 output. So similarly, if you are going for 5 cross 5 filter, definitely you will find with a 0 padding of 2. If you are going for 7 cross 7, then you are supposed to go for 0 padding with 3. This is a common example I have prepared so that you can have a basic understanding how you are going for convolution operation. So this is the concept of convolution and ReLU, where you have to use 0 padding and stride operation with convolutional operation to identify convolution process in case of your CNN architecture. So as I mentioned that there are many stages of convolution are there. So you can use the similar concept at different places. Similarly, the second level is pooling. So pooling is a mechanism to reduce the dimension of the image. So as I mentioned you that in case of neural network, people have used almost if you are using 400 cross 400 size image, you need to have 230 billion calculation in your neural network for finding the different weights in one pass. Just think that one iteration you need 230 billion calculation. So if you are going for pooling operation, that is supposed to reduce your calculation. So what exactly pooling operation is doing? So every image what you are considering, it is dividing it to number of sub-regions, and over that sub-region it is trying to go for max pooling or average pooling. So if you are going for maximum pooling, so maximum over that block is replaced by single pixel. So you can see here, so if I have a 4 cross 4 size image is there, I am dividing into 2 by 2 or 4 sub-regions. So each sub-region I am calculating the maximum value. So if you see 12, 20, 8, 12, 20 will be the maximum value. 30, 0, 20, we have 30 maximum value. 34, 70, 100, 12, 100, maximum value is 112. 37, 4, 25, 12, 37 is the maximum value. So I am saying it is a maximum pooling operation. Similarly, if I calculate the average value, it's an average pooling operation. So like that, mean pooling, max pooling, average pooling, median pooling, many kind of pooling can be possible. So these are some example of max and mean pooling. So as I mentioned that previously the images what you are considering 224 cross 224 64 kind of channels you are getting in case of your convolutional operation. If you pull it, it is reduced to 112 cross 112 into 64. Now just think, previously 400 cross 400 into 3 size image what you are considering, if you are going for a single pass of pulling, so it is trying to reduce into 200 cross 200 into 64 size image. So now if you are putting it into a neural network, the number of calculations will be tremendously reduced. So based on this concept, you can think that if you are going for number of passes inside the CNR architecture will be more than 1 or 2, you will find that your size of the operation or the operation you are performing through deep neural network will be greatly reduced. So this is an example of max pooling graphical representation, you can say. So once you are getting after several round of convolutional ReLU and pooling, you can go for flattening your data. So whatever output you are getting, you are supposed to flat it. So you can think something like this: after kind of several kind of convolutional ReLU and pooling, you are supposed to get several layers of data or several channels of data, and you are simply flattening the data, or you are arranging it in the flattened order, or you are arranging in the stack order. So this stack is supposed to be fed into fully connected feed forward neural network what you are being previously. So previously your data 400 cross 400 cross 3 was fed into neural network. Now maybe you can think of 100 cross 1 is fed into your fully connected neural network. So it will try to reduce the dimensionality problem. What previously you used to go for several calculations, it will be greatly reduced. So one thing you will find that, as I mentioned, that convolution with a ReLU operation is there. So ReLU is a kind of activation function. So we'll go for understanding that concept in activation function. So activation functions are mainly used in manage, max, out, ReLU like this. So with different kind of activation function, you are trying to generate different kind of output what is required for your system. So as you can see here, if you are using a sigmoid kind of application, you are passing the number in between 0 to 1. These are quite popular kind of architecture, sigmoid, because it interpretation is a firing rate. So you can say you are getting a very good firing rate using sigmoid kind of application, because it is giving you a very good non-linearity. But one of the main issue is that if you are using sigmoid kind of activation function, sigmoid outputs are not zero centered, so it is not giving you zero centered output. And again, if you are trying to implement using a computer, it is supposed to be very expensive in nature. So people started using tan H activation function. Tan H activation function is very good. It passes between -1 to +1, zero centric. But problem is that its gradient kills when it gets saturated. So when your system is getting saturated, so its gradient is killed. So people, that's why I started using ReLU activation function. ReLU is a rectifier linear unit, which is following some linear straight line equation. It doesn't saturate, very computationally efficient, converges much faster than sigmoid or tan S function. But problem is that it is not zero centered, it's starting from the positive value directly. So for any negative value function, it is supposed to give you zero output. So that's why people started using non-linearity function with a leaky ReLU, they are saying. So leaky ReLU has an advantage that it operates in the negative part of the function also. So it's not supposed to die, and definitely doesn't saturate it, computationally efficient, and it also converges faster than any kind of operation that you are using sigmoid or tan S. So that's why people have started using linearity function, using ReLU or leaky ReLU as a function. But the only problem in leaky ReLU is that your learning rate is supposed to be fixed carefully, because in your neural network, whenever you are using learning rate function, it is trying to be modifying your output based on the leaky, if you are considering ReLU function. So people started using leaky ReLU. But problem is that if you are using leaky ReLU, as I mentioned, that ReLU and leaky ReLU also, there is a problem of negative functions, or you can say if you are having negative input is there, it may not give you good performance. People started using tan S also, but tan S is not supposed to give you best output or good output. And definitely, if you are using a deep learning concept, sigmoid functions are fairly used or not required to use. So considering this concept, as I mentioned that CNN architecture, so there are several architectures are there. You might have heard with the concept LANet 5, AlexNet, BGG16, BGG19, ResNet 34, ResNet 50, GAN, UNet. So these are different kind of CNN architectures are there. Starting from 2012, AlexNet, there are many kind of algorithms are developed throughout the years. So this is a kind of LANet 5 architecture, initially proposed in 1988, but later on it got popularity in 2012 after AlexNet only. So as name in specify, it has 5 layers are there, or 5 convolution operation are there. That's why saying it as a LANet 5. Similarly, AlexNet is there. So as I mentioned, as you can see, it has also 7 layer of convolution operation is there. So you can see convolution with 11 cross 11, convolution 5 cross 5, 3 cross 5, 3 with 3 layers of 3 cross 3 are there. Similarly, BGC16 architecture is there, as the name specifies, and 2014 it is developed with 16 convolutional operation. So as you can see, currently people are using mostly BGC16 architecture for many applications. BGC16 got its popularity many a time due to its less complexity and good performing output. Similarly, there is a variant of BGC16 is there. It is called as BGC19 with 19 convolutional operation is there. In 2015, ResNet 50 architecture came. So as name specifies, it has 50 convolutional operations are there. I am not going much details on this. So it has many kind of blocks are there. Based on the blocks, uh, this architecture is got popularity with several applications also. So if you see this architecture, only advantage you will find over BC16 is there. It has residual blocks is there, and skip connections are there. Due to skip connection and residual blocks, many kind of operation what you are using BC16 is got reduced, and you with a less number of operation with less complexity you can extract many meaningful information and meaningful feature out of the CNN operation. So as I mentioned that ResNet has different variant 50, 34, 100, 152, like that many applications are there, including that nowadays 3D ResNet is there. Now people are quite popularly used ResNet architecture for different kind of application. So these are the theoretical concept of deep learning. Today I will go for several applications of CNN. So as we have studied this CNN architecture, as I mentioned that CNN and deep learning concepts are used in many part of the world for different kind of applications. So I will try to elaborate few applications which will be useful for us. So one of the first application is infrared and visible image fusion. So as the name implies, so there are many informations are there in IR data and visible data. Sometimes it is required for fusion. So as you can see, mainly IR images are used in many kind of military application. As you know, for night surveillance, visible images are not useful. And IR images are quite useful for night surveillance, like in armed force. One of the important tasks is to monitor the border of a country or different susceptible area using some camera. So IR cameras are installed at different part of borders with a long range application, where if a person or animals with a higher elevated temperature is moving in that area, it is supposed to be identified in the camera. But problem is that if you are seeing any IR camera, IR cameras are low resolution. So you may not able to get much information of the background. But definitely IR will give you a good resolution for object in the scene. So you can see here this image. So this is the image captured by IR camera. So this is the image from visual camera. So you can see the background information is quite clear in the visual image, whereas the IR image, you can see the object information is quite good. So the concept was to, if we can mix these two output, then it can be used for many applications, including the surveillance for military application. So in our lab at IIT Jammu, we have tried to develop some application. What we have done is we try to decompose these images using some kind of signal processing algorithm like NSCT or uh, bidimensional empirical mode decomposition to different feature level. Now the high frequency feature what we are going, so this high frequency features we are seeing it as an important feature for analysis, and we are giving it into a BGG19 architecture to extract more meaningful information and then fuse it using some kind of fusion algorithm. Mainly we have using additive fusion process, and the average component, that is the base component or the low frequency components, are directly added into the images to get a very good fused image. So you can see in the right hand side, so where the information for infrared and visible images are fused for some kind of images generation which will be used for surveillance application. So this is a kind of example you can see. So this is the infrared image where you will find that a person or a soldier is lying for firing position. In visible image, definitely the place is not clear, and I am trying to fuse both the images, so you can see the output what we are getting is shown here. And when we are trying to compare it with many kind of existing algorithms, so you can see here the information is quite not clear in other algorithms. Whereas deep learning models, so last two models are deep learning and one algorithm is CNN model. Last four are actually deep learning algorithms. So you can see the result is getting tremendously increased, or the information content on the image is tremendously getting increased due to use of deep learning concept. So this is another application where one person is standing here is visible in infrared image, where at the same location you can see even the person is standing there, visible image is not able to identify it. So if you combine both the information, you can see using the deep learning concept how the system will be able to identify a person is moving here. So there is a second application I will show, the background subtraction using residual learning, where background subtraction is mainly used to detect the moving object in a scene. So here what we have done, we have proposed an encoder decoder type network where ResNet 50 architecture is used as an encoding purpose. That's what we are exactly doing is we are giving input image frames as a input, or you can say frame for modeling the system using ResNet 50 architecture. As I mentioned that the ResNet 50 has 50 layer of CNN models which is trying to extract the features, and with the feature pooling module or FPM module, we're trying to boost the feature and feeding it into a decoder model to detect what will be the possible output for object detection. So you can see here, sorry, this is a kind of example. So where we have tried to go for many kind of pictures, almost I think 56 videos are there for CDNet 2014 database. So we have tried to get the output for all these kind of images. So you can see the last picture or the last column pictures are the result of proposed scheme. So when we are trying to compare it with the existing algorithm, we'll try to find that this algorithm or the proposed algorithm is found to be providing very good output with less misclassification errors. So this is a comparison database. So you can say it's a CDNet 2014 database. Uh, we have tried to compare with the deep learning and non-deep learning techniques. So you can see the top part is a deep learning comparison algorithm. So comparison of the proposed scheme with the deep learning techniques. So we'll find that the range what you are getting for average precision, decal and F measure value and PWC value is quite high as compared to the non-deep learning models. So you can see against non-deep learning algorithm, definitely the proposed algorithm is giving very good result. And if you are going for comparing with the many deep learning algorithms, so you will find that our algorithm is giving quite better result. So these are the cases for other databases like I2R and Wallflower database, which is quite popular. Third application is activity recognition. As you might be knowing, that activity recognition is a quite important part of now smart city surveillance. So you might be knowing that government of India is trying to install many camera at different places in the city to check what kind of activity is going, and if any non or you can say any violent activity is happening at any places in the world or any places in the city, it is supposed to be informed to central server so that sudden some action can be taken. Now, if you see, this is a kind of architecture designed by us where we are giving a violent and non-violent activity in the city, and we are trying to process it with a BGC16 architecture to identify what kind of activity is going. Now, you might be knowing that in Jammu and Kashmir, mainly Kashmir district or Srinagar area, you will find that many kind of stone pelting activities going different times. Now, controlling this with smart city surveillance will be quite useful. So you can think something like that. Whenever there will be stone pelting activity will happen, then server room will be contacted or server room will be given a signal that some stone pelting is happening and sudden action is required. So you can see here, this is an example. So n stone pelters mean stone pelters have not happened. Now you just see after a few times stone pelting will start, and just see stone pelting is coming as stone pelters. So it's a kind of application where stone pelting and non-stone pelting activity will be detected by using your server. So whenever stone pelting is happening, it is trying to say that stone pelting is happening here and please send some kind of rescue operation, or some kind of force is supposed to be sent to that location so that this thing can be controlled. So you can see some other application or some other kind of activity, or you can say some other kind of videos at different place, so where stone pelting is happening, and we are trying to identify stone pelting or non-stone pelting. So as you can see here that these videos are taken are actually from YouTube, for Times of India or AP is the channel where this which I've recorded. But definitely for stone pelting activity, we never installed a camera at the place where stone pelting is happening. But definitely, if we can install a camera, we'll able to real time monitor whether stone pelting is going or not. If since we don't have a currently smart city camera video is there, so we are unable to provide that video, but definitely it's a news channel video available in the YouTube. From there we have tried to
This
process it.
meeting is being recorded.
Another activity is autonomous driving car, so where you can see that a car is supposed to be navigated in a road where busy traffic will be there or not there. So as like in the cities like US, or you can say there are many cities in the US, they are going for autonomous driving car where no drivers are required. So your system will drive the car automatically. So the thing that the red car, what we are seeing, it is the driving car or autonomous driving car. So what exactly happening? This driving car has several sensors are fitted, or camera based sensor or non-camera based sensors are there. So first of all, it is trying to sense the lane. So while driving the car in US or many western part of the country, western countries, so you will find that they are trying to follow a particular lane while driving the car. So until and unless you are following a particular lane, or if you are to cross a particular lane, you have to give different kind of signals or different kind of alarm to change the lane. So as I mentioned that there are different sensors will be there, and these sensors are trying to predict the motion of the cars which are going behind or going on side or alongside of the moving car. So it will try to take a decision based on that. But this is not the only important part. Second part is that you have to park the car properly. So what exactly you are doing is autonomous driving cars should have self-parking option. So if you are giving the option, it will try to park the car at different places. Now just think, if you are having self-parking car parking option, either it will park in your garage or it will park in a place when there is a shade below your house is there. So you can see here below your house some shading is there, it is trying to park your car. But just think, if we are going with the Indian scenario where we are parking the car in the roadside, even in the foreign country also people are parking in the roadside, there will be parking mark will be there. Just see, this is an example where you can say in the Indian scenario that there is a big size truck is there. Now if you ask your car to park the vehicle self parking mode, it will try to ram into the back side of your truck. Reason is that it is finding that it is a very good parking side, because in front there is a wall is there and the top there is a shading is there. It will try to ram it. So there will be operational error, or you can say there is no good judgment by any autonomous driving car where it fails. So people started using deep learning based algorithm. So what exactly deep learning based algorithm is doing, it is trying to extract more meaningful information from the road. So whether it's a pedestrian, whether it's a car, whether it's a tree, whether it's a blank space, or you can say gap between two trees, or you can say this is a channel, this is a road, this is a kind of park. It is trying to take decision, and based on that it will try to park your car and drive your car on the road. And it is found that many kind of AI based application based self-driving cars are getting popularity these days. So it is trying to give a very good facility for your car parking. Next application is human pose estimation. So you can see here that any person human pose, is a model with a skeleton model where open pose is a case of kind of algorithm you might have heard of, which is a popular algorithm where the body structure is represented by 18 kind of features or 18 kind of nodes to represent any kind of action in the video. So further, this open pose is modified, and there are many variants are there, like blaze pose, mobile pose. There are many kind of algorithms are there which is popularly used for deep learning architecture to estimate or identify the action in a video. Deep learning algorithms are also used for cancerous cell detection. So mainly you can see some architecture like this where input layer you are giving different kind of images, and using convolutional operation you can identify whether it's a malignant or benign cancer is there. So you might be knowing that there are two kind of cancerous cells are there, malignant and benign, where benigns are supposed to be not growing and malignants are growing cancerous cell. So to identify this cancerous cell, uh, deep learning algorithm is found to be performing very well, where it is trying to detect whether it's a malignant or benign cancer. Another application is neural style transfer. So this is a kind of application. So you can think that, let us assume one foreigner came to Taj Mahal to visit the place in India, and he found that Taj Mahal is very good. So he buy a painting and he took his own place. Now, when he went to own place, he found that this Taj Mahal painting is very good, and in his own country, he found that Mona Lisa picture is there, and he want to transfer the style of this image or the painting to its Mona Lisa picture. So you can see here, based on this concept of deep learning, you can easily transfer the um, style of any painting to any other painting form as like shown in this slide. So different way you can modulate your local painting from the style of the picture you want. That's all from my side. These are few references for deep learning which I have used for preparing this slide. I am thankful to my student Manoj Panda who has helped me in preparing this slide. Thank you for attention. And last, I will say uh, deep learning is quite growing these days, and the concept is revolutionizing the industrial application also. And many industries are following deep learning concept in implementing and developing many technology which are useful for mankind or societal problem solving. That's all. Thank you. If you have any question, I will be happy to answer.